My topic for today is Node.js BFFs, sure way to the better micro frontends. So it's going to be a story about how front-end architecture has evolved in our company and how we are moving towards the micro frontends. So before I start, let me give some idea what Markplaats is. So basically, in short, it's the biggest classifieds platform or trading platform in the Netherlands. You can compare it with, for example, OLX in Ukraine. And it has over 8 million unique visitors monthly. And if you take into account the population of the Netherlands, which is around 17 million, you might understand that probably half of the population of the Netherlands basically uses our website regularly, which makes our work very exciting. And yeah, whatever we build, it actually impacts huge amount of users. So let's start with some definitions that I mentioned in the topic. So first, what is the micro frontend? So this is the definition that I choose for this presentation. And basically what's important in this definition that micro frontends, it's all about independently deployable applications that are somehow composed in a bigger application for the end user. So independently deliverable and composed are the most important things here, and I'll explain later on why. And by the way, if you notice, this definition doesn't say anything about the size of the micro frontend, because as I will describe you later, the size really depends on your needs. So the micro is different for different companies. So this is basically just a visual representation of that definition. So imagine you have a lot of front ends. In this case, it's 3. So each of them has its own repository. It might be multiple repositories. It might be a monorepo. It doesn't really matter. The most important thing here is that each micro frontend has its own build and test pipeline, so it can be delivered to the production independently. It runs on production independently, and then somehow it is composed in a bigger application for the end user. And this composition step is probably the most important part of the micro frontend, because, well, for the end user, the experience should be like it's just a single web application or website or whatever. So composition is crucial. So there are multiple ways how you can compose, but these are the 3, in my opinion, the most frequently used and the most important. So the first one is the infrastructure. Well, the infrastructure way of composition is very easy, and you can think, oh, it's maybe a bit of old-fashioned, because basically then the micro frontend is a separate page, and then somehow you have an HTTP server that routes requests to a specific page, and then that page basically is a standalone application. Build time allows us to build standalone applications that are basically reused across multiple pages. So think about, let's say, the common header and footer. Yeah, you can basically incorporate them in each page during the build time, and that's the way how it is served to the end user. And the runtime is basically the modern way, and eventually it should replace both the build time composition or infrastructure way of composing the micro frontends, but it requires some extra support. So you need to have extra support from your build tooling, but also depending on what kind of framework you are using, it also might need some help from that. So at the moment, we are using a combination of infrastructure and build time composition, because when we started this journey towards the micro frontend, it was several years ago. At that time, unfortunately, there was no production-ready ways of doing the runtime. So nowadays, there are few of them. I will mention them later. And actually, we are also actively looking into that, because we think that runtime composition is the future for that. So another definition that was in the title of this presentation is the BFF, or backend for frontend. So basically, it's a pattern where each frontend application has its own backend application. And the only purpose of that backend application is to serve the needs for that front end. So this is very powerful concept. So this is again the visual representation of that definition. So you have a front end application which only talks to its own BFF, and then the BFF can do a lot of other things like loading data from the downstream APIs, maybe going to database, and a lot of other things. So I think that micro frontends and BFFs are actually best friends forever. And why? Because BFFs enables a lot of cool features that otherwise would be really hard to achieve if you can only create a client-side application. So first of all, think about customizable API authentication and authorization. So in the browser, your web application can use cookies for authentication, but maybe your API uses tokens, JWT, or some custom build, which you don't want to expose to your end user for various reasons, for example, security ones. So in the BFF, you can basically terminate the token on the server level and then use cookie between the browser and the BFF. Another thing, you can have a very flexible A/B experiment setup. So A/B switches are special things that allow you to switch on and off a certain feature of your product runtime, maybe enable some feature for a certain percentage of users. So basically, without having a proper server-side support, you cannot do it properly because you need a way to not to deploy a certain piece of code to the user, to the browser of the user if certain feature is disabled for him. So again, the BFF gives you this functionality. Highly tailored data fetching and aggregation may be one of the most important features of the BFF because it allows you to optimize amount of data that you send between the server and the browser. So imagine you need to show some, I don't know, information about the product to the user. So under the hood, you might need to do multiple API calls to multiple APIs to basically get this all data that later on you should present to the user on the page. So you can do these multiple API calls in parallel on the BFF. So basically it would be server to server API call from the BFF to some other APIs. Then you aggregate this data on the server, and then you return a nicely created JSON that only contains data that is needed for that specific page to be rendered. And the last, but not the least, if you have something running on the server, you can, of course, do the server-side rendering. So, for example, for Markplaats, it's crucial because we depend a lot on the traffic from Google. So we care a lot about SEO, and Google likes when you give him rendered HTML. Of course, Google can execute JavaScript, so you can only return JavaScript, but our experiments showed us that if you return HTML immediately to the Google, it will prioritize you. Also, SSR is very good for user performance. So if you have a BFF, if you have something running on the server, you can do SSR without any problems. So let's give you some ideas about our journey towards the micro frontends. So where we were before migration. So the highest problem, the biggest problem for the business at that time was very long time to market. And when I say very long, it actually also depends on the company. So for some companies, weeks are not long. For us, even few days was quite long. So we were striving for time to market within a couple of hours. And at that time, we have two huge monolithic frontends, which were very tightly coupled with backend services. And sometimes it was really hard to deploy them. So sometimes we could wait even weeks to have a green build because we had a lot of end-to-end tests. They were fragile, they were failing a lot. And even if you want to deliver that one small fix to production, you still need to make the whole build green. What didn't help us is that we there was no clear ownership of the front-end code base. So imagine we had like around 8 teams, and we still have around 8 teams in our company, and each team contributes to the same code base. So it's really hard to basically argue, okay, who should take care about a certain piece of code. So next to that, we had some business logic that was leaking in the view layer. So all of that was causing the very long time to market, and business was not very happy. On the other side, we have developers. Developers also didn't like that setup because, first of all, it was old and legacy. There was a lot of legacy JavaScript. We also have a lot of, I don't know if someone heard about this technology called Java Server Pages, JSP. So at that time, it was our main technology for doing server-side rendering. No one likes it. So at the end, we have minimal developer happiness. So business was not happy, developers were not happy. So we need to do something. And we decided to apply this BFF pattern with micro frontends. So what we have achieved. So at the moment, we have much shorter time to market. Think about hours instead of days. We split our 2 huge monolithic frontends into 50, around 50. The number is going up and down, but on average, it's around 50 small, loosely coupled, but we try to keep them aligned backend for frontends. So each backend for frontend, each BFF is owned by a single team and tailored to a specific step in the user journey. So they are very small. Downstream APIs, which BFFs consume to get data, they don't leak business logic to BFF. So BFF and the front-end application, which BFF serves, they only responsible for the view layer. So they are only for representation layer. So there is no business logic rules, nothing. So it's all have been moved to the API. We also managed to make our builds much more stable because we're now doing much more integration tests and unit tests instead of end-to-end. And finally, what developers like the most, we have modern JavaScript and TypeScript stack, modern framework, while we use React, both on server and on the client. And as I said, we have very high developer happiness and productivity. So this is the picture that shows you what kind of architectural changes we did. So on the left, you can see in the right dotted box that we have few monolithic web frontends. We also have some app frontends that were supposed for the apps, but this is out of scope for this presentation. And on the right, you see the picture that we have at the moment. So this huge monolithic frontend was split into the set of the BFFs and also a set of the APIs that communicate by REST. And if you look inside a BFF, specifically this is the Web BFF, this is how it looks. So it all starts with the web application that is through CDN. It's served to the browser. Then the user has something in the browser. Then it makes some API calls, for example, to get the data. It goes through our cloud router. We use traffic for that. So the cloud router detects which BFF should be responsible for serving this request. And for the BFF, we use, it's very common setup. We use Node.js and we use Express.js. We have a set of middlewares that parse the incoming request. They do authentication. They do some common things like they check the XSRF token. They check what's your AB switch setup and so on and so forth. Then the BFF makes API calls to downstream APIs to actually get the data that's needed for the front-end application. And if the page has to be rendered as the HTML and returned back to the browser as HTML, the BFF can do HTML rendering. Nowadays, we are doing it with React. And then you return this response to the browser. So next to that, BFF has translations because we serve our UI in multiple languages. It can also be configured through properties, and it also produces some metrics and logs. I will explain why it's important to make sure that we know how the BFF behaves on production. So what is developer experience at the moment? So first of all, because BFF is small, it's very easy to run locally. You don't need to run every downstream API service on your local machine because it's HTTP. So basically on your local machine or development machine, you can only run that one single BFF that you're working on, and you can connect your local running BFF to API from any environment. Of course, except production for security reasons, but we have few other pre-production environments that have different kind of data, so you can connect to that. So you don't need to create some mocks on your local machine. You have some data that you can use to build the feature. As I said, because in one repository we have both client-side and server-side code, our front-end developers, they're responsible for writing both server and client-side code. We use Swagger as the contract between BFFs and APIs. So our backend engineers, they're building APIs. They provide us front-end engineers with the Swagger documentation, which we use to generate some TypeScript types, also to generate some API clients, and then we use that in our code base. We also heavily use TypeScript to share types between server, the BFF part, and the client, so the web application that runs in the browser. So that allows us to actually very easy to understand where the data comes from, what's inside, what fields can be used, and so on and so forth. And because, as I mentioned before, we have more than 50 different BFFs, we of course don't want to repeat our work. So basically we built quite a big amount of internal libraries to reuse some common functionality. One of the most important libraries, for example, is design system. So the UI, of course, of different web applications should be consistent for the user. So we don't want every developer to re-implement the button, the drop down. Everything should be in the same style. So that's why we have a design system which provides common components and styles. And we have very clear ownership. So one BFF, one team. So the team owns that BFF, the team deploys that. And we have a very clear guidelines how to do PR reviews. So if for some reason you need to do a change in the BFF that belongs to another team, there is a very clear process to do that. So one of the challenges that we faced once the amount of BFFs was growing is how to keep them aligned. Because if you don't keep this under control, at the end you will have different kind of implementations, multiple solutions for the similar problem. So at the end, we decided to come up with the approach that is now known as a golden path stack. So the golden path is the definition, I think it was introduced by Spotify guys. So they say that the golden path is opinionated and supported paths to build something. So basically we did the same. At that time, we didn't know that it's called like that, but now it has the name. So basically, the idea is that you provide for each team, you provide the stack that they can use. And this stack is very well supported and maintained by the platform team. So if they use it, they can solely focus on building their product features. They don't need to take care about managing like updates, security fixes, and so on. So everything is up to date. Everything is guaranteed to work nicely together. But if for some reason they want to do something different, they can do it, but of course they will pay extra price for that. So what's our golden path stack? So on the client side, as I said, we have a design system which contains a lot of common styles, components, images, fonts. We also have some shared React applications like header, login dialog, footer, because they look the same on every page. We also share the type definitions. So for the data that is being used, and we share translations. There is a lot more, but these are the most important. And for the server part, we share all the Express.js middlewares. So all the BFFs, they behave exactly the same on the server. We have API clients, so you don't need to write your own API client to load the data from a certain API. We have a library to do React server-side rendering. We have libraries that do metrics, logging, and tracing. And also we have common type definitions. So now every developer has a stack to build, but that's not the end of the story. You need to build and deploy your application to production. So here we also provide the shared tooling, because again, we want the developer experience to be consistent across BFFs. Doesn't matter on which BFF you're working, you have the same way of building it, the same way of deploying it. So people can switch the teams or can contribute to the front ends that are built to another team, and they don't need to learn new tooling. So what we have a shared build config. We use Webpack, Babel, ESLint, and TypeScript. So I think it's a very common choice nowadays. We have also multi-stage Docker build, which we use to basically run all the tests and then run it on production. We do automatic dependency updates with Renovate. So you don't need to basically manually check or if there is a new version for the library that I'm using. Renovate will do it for you. We also have automatic builds for master and pull request. So you just create a pull request, and then all the tests will be built. And if they're not green, then you cannot merge your PR. And if the master is not green, then you have a much bigger problem. You cannot deploy, which is a very bad situation. You don't want to be in that. And we also have automatic security updates and scans with sneak.io. So the sneak.io can create pull request if dependency of your sub-dependency has a known vulnerability, and they have a fix for that. And on the deploy side, as I mentioned before, we use A/B switches to basically detect if feature is available to all the users or only to some part of the users. We also have canary releases where you can release half amount of services with the new version, half amount of services with the old version, and then compare how to behave. We have one-click production rollback. I will tell you later on why it's so important. We also have CDN integration. So basically the web application that we have is not served by the Node.js. Well, you all know probably that Node.js is quite bad in terms of performance when it comes to serving static files. So that's why in production, the static files are served from CDN. And we have the tool that gives us the overview of all the dependencies. Think about the NPM packages that we use on production. So this last, I think it's a very important thing, especially if you run 50 BFFs on production. So this is how this tool looks like. As you can see, it gives you an information about the certain service. So in this case, it's called Ad Manager Web BFF. You know the team who is the owner. In this case, it's a buyer's team. You also have some information about this service, like for example, how much of the TypeScript is used, what the stack, when it was last deployed. But the most important is this right side. So it shows you which dependencies, which outdated dependencies are used at the moment on production. And this is very critical. So if you only own maybe one or two services, yeah, you can probably just check package.json file and ensure that you're not using some outdated or maybe the version that is deprecated already in your company. But if you're running 50-something services, you cannot do it manually. Yeah, so this dashboard already gives you a nice overview of how your service is doing. Maybe you are already using some outdated version and you need to take care of this. So this is the tool that we built internally, and it helped us a lot to keep under control and to keep the code bases of all the BFFs aligned. So the next thing is testing. Yeah, you don't want to deploy the code that is not tested. So as I mentioned at the beginning, when we had a huge monolithic front ends, we heavily rely on Selenium end-to-end test. We all know that they are slow and fragile. So that's why in the new setup, we decided to focus more on unit tests and integration tests. So luckily, there is a very well-known approach called testing trophy. It is described by Kent C. Dodds. There is a lot of webinars and online resources about how to use it. So we decided to apply it because it works for us very well. So we tried to create more unit and integration tests, so you can only run them inside the Docker container. So you test the BFF code base itself. And we only create Selenium tests for business critical flows. So those flows that you for sure don't want to be broken on production. So think about like authentication flow. You definitely want your users to be able to log in. So these flows are still covered by Selenium end-to-end tests, but we try to keep amount of those tests very low. Why? Because we want to to be able to independently deploy each separate BFF. And if it's end-to-end test, your test already depends on other services. So there might be a situation where you cannot deploy your BFF just because another service that the test depends on is broken. But it's not your problem. You cannot fix it. So why you should not be able to deploy your feature? So that's why we keep this Selenium end-to-end test at the very low amount. And for the rest, for everything that we don't cover with end-to-end, we rely on metrics. So instead of testing that everything is flawless, there's no bugs, we allow certain level of issues, but we keep close eye on them. So if after deploy we notice that some important metric goes down, or maybe amount of error goes up, then remember I told you about this one-click rollback. This is the feature to your rescue. Yeah, you click one button, you roll back this deploy, and then you have time to actually fix it properly. You don't affect the users. So that's why alerting and monitoring is important, because we write less tests, we depend more on alerting and monitoring. So on the client side, we use Datadog. So if you're using Sentry or Trace.js, I think, so this is the very common, I think it provides the similar functionality. So basically it captures all the logs that happen in the browser, plus next to it, it also measures the real user, it does real user monitoring, so it captures performance metrics, such as core web vitals. So next to that, we also do some performance test with speed curve. But to be honest, Datadog can fully replace speed curve as well. And on the server, we fully rely on the Datadog. In the past, we were using Grafana and Kibana for various metrics and logs, but Datadog has everything in one UI nicely working together. So most important thing on the server is tracing. So basically, this is the way how you can profile and monitor distributed application. So when request comes in, it first handled by one BFF, then you send request to an API send request to a database. So tracing allows you to see this how request is handled across multiple services, which services are involved, what was response time for each service, what was error rate. So it gives you the visibility on how the actual request is handled by your system. It gives a lot of insights. You never know how your system works in real life. We also have very common access error logs. Yeah, we track that. Datadog gives you out of the box some Node.js and Docker metrics. So think about like CPU usage, memory usage. For the Node.js, it also gives a very important event loop delay metric. We all know that, Node.js by default is single-threaded. There is a main thread. And if you do too much CPU blocking operations, your response times will grow, and event loop delay shows you, okay, how much free room in the event loop is still there. And as I mentioned, we also track response status and latency. So after you deliver a certain feature, we have a dashboard where you can check how these metrics behave. And if Datadog see that, oh, there is something wrong going on, it will immediately see on the dashboard. So then you can decide either you roll back the feature that you just deployed, or maybe it's still okay, and maybe just disable the A/B switch. So once if we already start talking about performance a little bit, so let's deep dive into that. So as I said, each web application or front-end application only uses its own BFF. So there is like one-to-one mapping, and this is very important for stability, because you 100% sure that whatever happened to other front-end services, it will never impact yours. So they are fully isolated. All the static resources we serve from CDN, so it is independent. So other front-end developers cannot break your work. Well, if something goes wrong with the API, then everyone is affected, but at least each front-end is independent from other. We also keep our BFF small, and by small, I mean that, well, the smallest deliverable at the moment is the single page. Some BFFs, they serve one single page. You can think about, let's say, home page or login page. Some BFFs serve several pages that are part of the user journey, but still they're very small. And if we have an increase in traffic to a certain feature, we can simply increase the number of instances of that specific BFF. So if we see, like, let's say, a huge increase of traffic to the home page, we just increase the amount of instances of that BFF. So that help us to keep under control the costs. And especially if you're running in the clouds, in the public clouds like AWS, Azure, Google, it's very important. You don't scale a heavy application, you scale very small applications, so it will be cheaper. We're also able to do server-side rendering, as I mentioned, but we do it very carefully. So we only do it for bots. We do it for the app shell, so the initial HTML, and we also do it for user-critical content. The main reason for that is Node.js is very sensitive to CPU blocking operations, and server-side rendering is a CPU blocking operation. We are now experimenting with offloading the SSR to worker threads. So you can run additional threads in Node.js and then offload the CPU blocking operation to those threads. Then the main thread still can accept incoming requests. So very cool feature. I'm looking forward to see it in real life. We do a lot of calls to downstream APIs to get the data, and for performance reasons, we do it in parallel. So even if you need to do like 10 calls, because you do it in parallel, basically the time you wait is basically you just wait for the slowest API call. You don't wait for the total amount. And we also do the smart load balancing. So we have a load balancer, internal load balancer between each BFF and API, and it basically routes your request to the closest one. Maybe the API can also run on the same machine as your BFF, so then the API call will be faster. And yeah, as I mentioned before, we use the CDN, so each front-end application is using the same CDN. So this is our way to reduce amount of, so to deduplicate the static assets, and so each front-end application loads as less as possible the resources. So what are the pros and cons of the approach that we take? So, well, the pros are very obvious. We have huge improvement of time to market for product features. This is especially what business likes. For developers, we have much smaller, isolated and maintainable code base. So it's very easy to grasp what's happening because you know that this repository is responsible for this feature, nothing else. It's very well isolated. This approach is a very good fit for the scalable organization with decoupled and autonomous teams. And what do I mean by that is because we can easily transfer the ownership. Yeah, so for example, we have a new team that say will be only responsible for some piece of functionality. We can transfer the ownership of the BFFs to them because BFFs are small and they have their own isolated domain. And because organization are changing over time, the new teams are created, old teams are dismissed. If you have micro frontends, if they are small enough, you can just transfer their ownership. You don't need to split them to make them smaller or maybe to combine them bigger. And that helps a lot. And because each micro frontend with each BFF is small, we can rewrite it piece by piece. So imagine we have, let's say, React 18 coming soon. Well, it's already available. Maybe we will decide to use some cool new feature of React 18. So instead of applying it to all the web applications at once, we can do it one by one, and they will still work nicely together. But of course, everything comes with a price. So there are some cons. You will have a lot of duplicate dependencies because each separated front-end application depends on its own version of React, its own version of other libraries. I don't know if you're using Redux and so on and so forth. So if you don't do any optimizations, by default, the end user will just download more bytes. But there are techniques how to optimize that and how to deduplicate. With team autonomy, it's a great thing because it's proven that autonomous teams are much faster when it comes to deliver the business value. But it can lead to platform fragmentation. So if too many decisions are up to the team, at the end, after certain time, each front-end application will not be similar to any other, and it will give a lot of friction going further. So that's why you need to keep it under control. As I said, you need to keep all the front ends up to date, and if you have multiple of them, it's an extra effort, but you can automate this, what we did. And eventually, CI/CD pipeline will become a bottleneck. So at the moment, we deploy, imagine we can deploy 50-something services, so the Jenkins should be very high performant because next to these deploys, you also have a lot of pull requests that are also run in Jenkins, a lot of PRs with dependency updates that are created by Renovate or Sneak. So everywhere Jenkins is being used. So CI/CD pipeline is very heavily used here. So how we do decisions? So this is a very important aspect of the micro frontend architecture, because the micro frontend architecture shines when you have autonomous teams and they can deliver the features and they can focus on building their product. But from the other side, you still want to have the solid platform that is aligned and consistent. So you can, of course, try to ensure it on a technical level, but I think that it should be solved on the organizational level. And this is the way how we solved. So we have a front-end chapter. In different companies, it's called different. Maybe you know it as a guild or squad. So basically, if you're a front-end developer, doesn't matter in which team you are part of the front-end chapter. So you have a way to collaborate with other front-end developers and align with them. Basically, you share knowledge, you ask questions, you solve the problems. So we make sure that if the problem is solved in one team, every other team knows how to solve the similar problem the same way. And it also encourages the collaboration. So if you have a nice feature that is not tightly coupled to your specific business feature, you can build a shared library and other front-end developers can reuse it. We also want to document every important decision that we make. So that's why we use architecture decision records pattern, or ADR. So basically, it's a very simple document where you describe what the problem you had, what's your decision, what are the alternatives of that decision. So it answers the question like why we do things in a certain way. It's very important if you want to onboard new developers, or if developer is switching the teams, because in the code he can understand, okay, guys, I see that this is solved this way, but why? Well, of course, we know that there is no silver bullet, so every decision has pros and cons. So it's nice to have it documented because it reduces amount of questions in PR reviews, because, well, there is an ADR that a lot of ADRs that answer a lot of questions, so it makes it easier to review pull requests to make sure that what we are building is actually aligned on the technical level. And the last but not the least is the Tech Radar. It's a very nice tool. Basically, it describes what technologies like libraries, toolings, just architecture approach you want to use or you don't want to use. And I think the last thing, that what you don't want to use, is even more important. So imagine in our company, we decided, okay, we don't want to use the Moment.js anymore because, well, it has a lot of downsides. Like, for example, the bundle is quite big. We think that the DataFNS is much better for performance. So we put Moment.js on hold in the Tech Radar, and we put DataFNS in adopt. What does it mean? It means that whenever you build a new feature, you should not use Moment.js, but you should use DataFNS instead. And if you already have a lot of functionality that is already using a Moment.js, well, you don't need to change it immediately. Well, that's not practically possible, but you should plan it. You should reserve some time, and whenever you have time to work on your tech debt, you should think about migrating Moment.js to DataFNS. So this is a simple example, but it shows you how we make sure that the code bases in so many different BFFs, we try to keep aligned over time. So they're not consistent, but they are eventually consistent. So what are our plans for the nearest future? So as I said at the beginning, we think that runtime composition is the best way to compose micro frontends because it's much more flexible. So at the moment, we are looking into Webpack module federation. The only challenge is how to make it work nicely with React SSR. So nowadays, there are a few libraries that are doing that. None of them is production ready, unfortunately, but we build a proof of concept to make sure that we know how it works. And if there is no major performance issues or whatsoever, we will definitely use it. So what we want to achieve, we want to make sure that the minimal delivery artifact is the single React application. So at the moment, the minimal delivery for us is the whole page, but you can imagine on one page you can have multiple independent React applications. So we want to be able to deploy standalone React applications. And of course, we would also would like to update like shared features, for example, header across all the website using single deploy. So this runtime composition will allow us to do that. So this is the end of my presentation. I would like to thank you for listening, and yeah, looking forward to answer your questions.
We have several questions in our chat.
Yeah, I see. So the first question, how do you keep infra updated on all micro frontends and BFFs so that they are aligned? Good question. So let me interpret it how I understand. So because infra is a very broad term. So if you talking about the infrastructure that is used runtime, so we use the same Docker file across all the BFFs and micro frontends. So that's the way how we ensure that we run them on the same infra on production because we use the same Docker file. If you're talking about the build and deploy infrastructure, so we also do it by sharing the same, for example, Webpack configuration or Babel configuration. So each repository has a copy of the file, but we have a separate library, a separate NPM package that contains the common Webpack and the common Babel configuration. So basically, each micro frontend just have a link to this infra, how it's configured. I hope I have answered your question. If not, feel free to ask another question in the Q&A. So then the next question, where do you keep shared dependencies like header component and how each micro frontend consumes it? Do you have some kind of private internal artifactory storage to store shared packages? In such case, you might need to release each micro frontend every time once you update every shared library, right? Yes, you're right. So this is the challenge that we have right now. So we have our own internal repository. We use Nexus, but it's very similar to Artifactory. And at the moment, for example, the header, we combine build time. And yeah, that's the unfortunate downside that if you update the header, you need to redeploy all the micro frontend that consumes it. So that's why I think the runtime composition that we are currently working on is the right solution, because then you can deploy this header micro frontend independently, and then it will be updated runtime. So it will solve this problem. Also a question from Stanislav. So you propose to reduce scope of any big part of any website to a single full stack autonomous solution, right? For example, user profile page, which every pretty big site has, we can consider as a pair of client-server site, which put inside a Docker container by developer. Do I understand correctly this conception? Yes, you understand it right, but this concept, you should think, do you need that? Yeah. So in our case, we want this because this piece of functionality, let's say the logging page, is owned by a specific team. So we have a team that is responsible for users to be able to log in, to register, and so on and so forth. So they want this application to be independently deliverable. So they want to deploy the logging page independently from the rest of the website. So if you have this requirement, then yes, just make it a separate web application with its own backend, put it in the Docker, and then you can deploy it as a standalone. So related to this conception, every developer can work on the solution. Is it possible to measure effectiveness of every developer and avoid code anti-patterns in case pretty big site? Well, good question. This is what one of the challenges. If you have a lot of code bases that are deployed independently and people work in a different teams, and the teams are autonomous, which means that each team build features independently. If you don't take any extra measures, then of course, eventually there will be anti-patterns. So that's why we have this front-end chapter to ensure that we promote best practices. We promote the right way to solve things. And this helps basically to keep the whole platform consistent. It's a big challenge. Yeah, so this is one of the biggest price that you will pay if you will split your monolith into smaller chunks, because if you have one big monolith, it's much easier to control how everything is going, but it also slows down every separate developer. If you give a bit more freedom, every developer will be much more productive, but then someone has to keep eye if every developer, like all developers, going the same direction. Well, this is one of the responsibilities of the architect in our company. Another question, what framework do you use for SSR, or is it a custom server? Well, good question, one of my favorite. So when we started several years ago, we were looking into Next.js, but at that time, the performance of the Next.js SSR was very poor. I think it was version 7 of Next.js. So we built our own engine. To be honest, it's very, very easy to do. Yeah, so there is React DOM render to static string or render to node stream. It's very trivial to build your own. And you can only build the features that you need. So at the moment, we are using our own implementation because it's really fast. But we're also looking into using the solution from the Next.js. We don't want to use the whole Next.js. So we are waiting when they will allow to basically only consume the SSR rendering part from their framework. So whenever it will be available, I think we will definitely look into that. Question from Yuri. Do you have some kind of orchestration app to control all micro frontends and, for example, to provide shared depths as external for other micro frontends? No, we don't have this at the moment. So our orchestration only works on the level of HTTP load balancing. So as I mentioned, each micro frontend is completely isolated from others, so it can be run in full isolation. So that's why we don't need this orchestration application to control how the micro frontends. But I think what you mentioned will be very important for runtime composition, because once you have a runtime composition, you will have a host application and the application that will be loaded into this host, and this host application will be this orchestration app that you mentioned. But we are not there yet on production, so we're only building a proof of concept for that. Why not subdomains or lazy load instead of bunch of front-end repos with a lot of same dependencies in same cache? To be honest, I don't understand this question. Why not subdomains, lazy load instead of a bunch of front-end? Maybe let me explain how we load static assets. So basically, each micro frontend is responsible for basically serving all the static resources it uses, like all the JavaScript bundles, CSS, images. But of course, there is a lot of resources that are common across multiple front-end applications. So if you use the same CDN bucket for them, and if you use the same build process, you can be 100% sure that, for example, the image, if it has the same content, if it would have the same URL, doesn't matter which micro frontend build creates it. So we put all the static assets from all the frontends into one bucket, and this is the way how we do duplicate it. So basically, still, each micro frontend is isolated, but the end user will only download, let's say, the logo image once, because every micro frontend will have the same URL for this image. And because it's very aggressively cached, the user download it once, and then it's served from the browser cache. I hope I answered this question, but sorry, I did not get it fully. One more question from Yuri. Do you use monorepos for what needs? Another good question. So we have a discussion in the front-end chapter, should we use monorepo or not, because we have a few people that are really big fans of monorepo. So far, our approach for monorepos is, unfortunately, we cannot use them because we have, from the deploy perspective, we have this one-on-one reference, one repository, one Docker file, one deployable artifact. But once we fix it, we can put several BFFs in one repository. So with one repository, it's monorepo, but you can still deploy multiple services out of it. So we think it could be a good fit for a team. So let's say your team owns, I don't know, several services. That's the common pattern. On average, every team in our organization owns like 10 different micro frontends. So sometimes it makes sense to put them into one repository and to basically simplify the code reuse. So we see the potential of monorepos, but because our deploy pipeline has this limitation, it cannot deploy multiple things from one repository. We are a bit stuck on that, and we depend on our DevOps team to solve it for us. So we would like to use them. We see a good use case for monorepos, but we don't use them at the moment. And I think, there are more questions. So while I'm answering the questions, the more questions are. Question from Kostya. Do you have cases when one BFF should use some part from another BFF? How do you do that, if yes? Well, we try to avoid that as much as possible, but of course, there are exceptions. So sometimes one BFF should use part from another BFF. You can still do it because at the end it's just two web applications. You can still do, the API, the HTTP call to another application. But the only requirement that we have is that if you depend for some resource, it can be like an endpoint that returns you data, or maybe you depend on some JavaScript file that is served by another BFF, you should always consider graceful degradation. So you should always build the feature in assumption that that resource might not be available and your functionality should work. So basically, if it's a non-critical, maybe it's like some extra feature, like nice feature to have, but if it doesn't work, nothing wrong happen to the user, then maybe you can consume another BFF. But as I said, this is the violation of one of the main rules. So we have very few exceptions that do it. So I would rather think of another approach. Maybe if you want to reuse some piece of another BFF, maybe it makes sense to make it a shared library and maybe reuse the code, but not the output of that code.